Alright everybody, we are going to take a look today at 12.3, an introduction to probability. So much of this stuff you've already seen before, so it shouldn't be anything crazy new for you. Okay? So, daily question. If you roll a red six-sided die and a white six-sided die, what are the different possibilities that might occur? We are not finding the sum, so a red 1 and a white 3 is different than a red 3 and a white 1. Okay, so you have 6 different possibilities, okay, for the first one. So for your red, 6 possibilities. And for the white, you have 6 possibilities. So if you're trying to find your different outcomes, you can take these two things, multiply them together, and you get 36 different outcomes. Okay? So this leads us into something called theoretical probability. Okay? Now, theoretical probability is the number of desired outcomes divided by number of total outcomes. Now again, theoretical is just something that should happen. So if I flip a coin twice, I should get a head and a tails because it's 50% for one, 50% for the other. So this is theoretical. Okay, it's extremely different than experimental. Okay. Please keep that in mind. We had a nice conversation about that the other day in class, so it should be relatively similar for you. Example 1, when rolling one die, what's the probability of rolling a 4? So for part A, how many 4s are on a die? Just 1, so you have a 1 out of 6 chance. Okay. What about for part B, rolling an odd number? So there are 3 odd numbers, 1, 3, and 5. Okay. So 3 out of 6, 1/2. Okay. And lastly, rolling a number less than 7. Well, how many numbers on the die are less than 7? All of them. So 6 out of 6, which is 1. So your probability is 1, 100%. Okay, it's all good. Example 2. You put a CD that has 8 songs in your CD player. You set the player to play the songs at random. The player plays all 8 songs without repeating any song. What's the probability that songs are played in the same order they are listed on the CD? Okay. Well, what that means is, okay, you want a 1 out of 8 chance for the first song you play in the first spot. So first spot, second, third, fourth, fifth, sixth, seventh, eighth. The second one, there's only 1 song out of the 7 that can be played in that spot. Then there's 1 out of 6, 1 out of 5, 1 out of 4. You kind of see where we're going with this. 1 out of 3, 1 out of 2, 1 out of 1. Alright? So you can take your calculator, and I can do this all the way across. 1 over 8 times 1 over 7. Okay? And we get a very, very small number. Okay, so it's going to be 1.240079365 times 10 to the negative 5. Okay, so what that's saying is if I move that over 1, 2, 4, oops, sorry, 0.0000124000793. It's a very low chance, okay, of that event occurring. Which makes sense because if it's random, like anyone here has had an iPod before, it's crazy. You have 4 favorite songs in a CD. What's the probability that 2 of your favorite songs are played first in any order? So when your first chance is happening, you have 8 different songs, alright, and there are 4 songs on there you want to listen to, so it's a 4 out of 8 chance. And the second time, there's 3 left out of 7. So let's check out that probability. So it's 4 out of 8. Times 3 out of 7. Okay, 0.214285. Okay, so basically if you want to know the percent, okay, that's your probability, that's all well and good. And if I would do math fraction enter on the calculator right here, okay, you can't really see, there we go, you would get 3 out of 14. Okay. This is also saying if I multiply this by 121.4%, just so you guys are aware of decimals and percents. Example 3, you flip a coin 5 times. What's the probability that you'll get all heads or all tails? So what that's saying is 1/2 times 1/2. This is actually a very strangely familiar question because you did this in your packet. 1/2 times itself 5 times gives you 1/32. So it's a very, very low possibility or probability of that happening. Alright, on to the back. So 3 more problems to go. If you draw a card from a standard deck of playing cards, what's the probability that it will be a face card? Okay, so you have to imagine how many face cards are in the deck. If you guys need one of these, just kidding, here they are. Okay, boom. We have these in class. You guys can check them out. If you count how many face cards there are 3 times 4 is 12. So it's 12 over 52. Now, I want you to reduce that down. In fact, I always want you to reduce stuff down. So 12 divided by 52, type that in. I can hit math, enter, enter. I get 3 over 13, which should make sense because for each suit, there's only 3 face cards. If you draw 2 cards from a standard deck of playing cards, what's the probability to get 2 hearts? Well, the first time when you reach in there are 13 hearts. Again, use the chart if you need to. 13 out of 52. And the second time, there's 12 left and out of 51. So I can take these 2 fractions, I can multiply them together. Okay, math, enter, enter. 1 out of 17 chance of that happening. Okay, again, you always want to reduce fractions. Reduce fractions. Okay. Alright, last problem. You throw a dart at an 18-inch square dartboard. There are 3 concentric circles with radii 3, 6, and 9. So, 18, 18, I've got 1, 2, 3. Okay. The innermost circle has a point value of 10. Then the middle one has 5. This has 2. And if you miss the circle and hit the rectangular board, you get 0, no points. If each dart is likely to hit any point inside the square board, are you most likely to get a 0 or to get 10 points? Okay, so here's what we're doing. I'm looking at the area of my 0 points. So the area of 0 points is area of 0 is 18 times 18. Okay, so 18 squared gives me 324. What are we talking about inches here? Inches squared. Okay. The innermost circle is a radius of what? 3. So the area of the innermost circle is pi r squared. So in this case, it's pi 3 squared. So I can do second caret, there's my pi button, times 3 squared. And I get an area of 28.27 inches squared. Okay, so question now. Are you more likely to get 0 points or to get 10 points? Well, look at your area. I have 324. Yes, my handwriting's terrible before you're saying it out loud. 324 inches squared, and down here I have 28.27 inches squared. Okay? So, I am more likely to hit the back for no points due to the fact that the area is greater. But I just realized something. What are we forgetting? We need to find the area of the big circle, don't we? Yep. So 324 is the area of my entire square. I want to subtract from that the pi r squared, pi 9 squared of the area of the big circle. Thanks guys for reminding me, I appreciate that. So what we can do here is 324 minus pi times 9 squared. Oops, that ain't squared. Okay, and we get 69.53 inches squared. So the area of no points, okay, is actually this. Okay, so, and again, the same thing remains here. What I'm doing is, just a quick recap because I completely butchered that problem. You find the area of your big square, you subtract from it the area of the big circle. So that gives me all of this area. Okay, all the area in which I can get a 0 on it. Okay, but then down here, this is just the area of the innermost circle. This is really a lot bigger, so therefore you're more likely to hit that if you're throwing it at the dartboard. Makes sense. Okay, so this is a good problem. Expect to see that one again. Hint, hint, nudge, nudge. Wink, wink. Okay, so that should be good. As always, keep up the good work. If you have any questions, feel free to ask. And as always, good luck. We are all counting on you.